Hello viewers, I am Kausalya. Today we are going to solve problems on AC parallel circuit. The problem is in the circuit shown in figure, the voltage across the 5 ohm resistor is 60 volt. Find the total current. So here this is your given diagram, right? The voltage across this 5 ohm resistor is 60 volt here. You see, as this is a parallel circuit, the current usually gets divided, right? So you see here I is the total current and this current gets divided into I1 and I2, right? Now you see we know the voltage across this resistor and we know the value of the resistor. So we can easily calculate the current that flows through this 5 ohm resistor. Yes? Yeah. So here you see the current through the 5 ohm resistor is 60 by 5. That gives the answer of 12 amps, right? So if you want to represent it in the form of rectangular form, you can write it as 12 plus J0. Right. Now the next thing is the voltage. Right. So we are calculating the voltage in this part, right, for this branch. So let this voltage is represented as E2. So E2 is given by V is nothing but I into R, right? The value of I is 12, and what about the value of R? Here we should not say as R, here it is Z, right? So the total value is 5 minus J5. Therefore 12 into 5 minus J5, that gives the answer as 60 minus J60, right? So you see these are all parallel circuits, right? So voltage across this part will be equal to voltage across this part, right? So voltage across this branch is equal to voltage across this branch, and again the same voltage will be here also, right? So you see, so E2 is equal to E1, which is equal to E, because it is a parallel circuit here. So now you see the value of E1, that is voltage across this first part, is also the same, that is 60 minus J60. Therefore here E1 is 60 minus J60, and how to calculate I1? Again E1 by Z. We know the value of E1, and what is the value of Z here? The value of Z for this first part is 10 plus J4, right? So therefore here it is 10 plus J4, right? Now we are going to convert this rectangular coordinate to polar form. So when you convert this rectangular coordinate to polar form, okay, our division becomes easier. So just divide these two numbers. So that gives the answer as 7.878. And now I am going to move this angle to the top. So when you move this angle over here, this plus becomes minus. Therefore minus 45 degree minus 21.80, that gives the answer as minus 66.8, right? Now again we are converting this current I1 into rectangular form here. So here we are asked to find the total current. So what is the total current? You see from this diagram, the total current is nothing but I1 plus I2 is nothing but I, right? So therefore here we know the value of I1, right? Already we have calculated the value of I2. Yes? So just we have to add those two things. So you see here, this is your I1 value, right? This is your I1 and this is your I2. So just substitute it here and add. And finally you see here the answer is 16.75 with an angle of minus 25.6 degree, okay, amps. So this problem gets over here. We will move to our next problem. For the 4-branch parallel network of figure, find the total equivalent impedance and the current, right? So here you see, this is our given circuit. We are asked to find the total impedance and the current, right? So here we are having a parallel paths, right? So we are having 1, 2, 3, 4, 5. So 5 branches here. So we are going to calculate the admittance first, as they are connected in parallel and we have lot of branches. So first we start with admittance. So we are going to calculate admittance for these individual branches and then we are going to proceed, right? So here you see, first we are considering this branch, right? So this y1, it is nothing but you have to take the reciprocal. So 1 by j5. So that gives the answer as this j, okay? J in the denominator, whenever it is moved upward, it becomes minus j, and 1 divided by 5 gives 0.2, right? And the next thing is y2. And here this y2, here it is nothing but 3 plus j4, right? So y2 is equal to 1 divided by 3 plus j4. Here we are taking complex conjugate. So complex conjugate is nothing but you have to change the sign of this term and you have to multiply the term with both numerator and the denominator. So 1 into 3 minus j4 divided by 3 plus j4 into 3 minus j4, right? So here this contributes the formula of a plus b into a minus b. So that gives a square minus b square, right? So here in the place of a I am having 3, in the place of b I am having 4j, right? So a square is nothing but 3 square minus b square is nothing but 4j the whole square. So 3 square is 9 minus 4 square is 16, and what about j square? That gives another minus 1, right? Therefore 9 minus of minus 16 becomes 9 plus 16. So 9 plus 16 gives the answer as 25 here, right? So again when you solve, we are getting the answer like this. This is your y2. And the next one is y3. Similarly for y3, you see here I am having 5 minus j10, right? So therefore y3 is equal to 1 divided by 5 minus j10. So here again you have to take complex conjugate. So once you take complex conjugate and solve, finally we are getting the answer as, you see, 0.04 plus j 0.08 mho. And the next thing is, consider this branch, right? So 1 divided by 10. Therefore, this gives the answer as 0.1, and here 1 divided by 2j, right? And again you see here we are having a capacitor. So therefore there is a minus. So 1 divided by minus j2, that gives the answer as j.5 mho, right? So you see here we have calculated the value of different admittances. The total admittance value is given as y1 plus y2 plus y3 plus y4 plus y5, right? So now just substitute the values of all these things and simplify. So when you simplify, you see finally we are getting the answer as 0.26 plus j.22. Again we are converting this to polar form. And the next thing is we are asked to find Z equivalent, right? So Z equivalent is nothing but reciprocal of the Y equivalent. So just take the reciprocal here and we are getting the value of Z equivalent as 2.936 with minus 40 degree. And the next thing is we are asked to calculate the total current, right? So again current is given by the basic Ohm's law, V is equal to IR. So here we are using E is equal to I into Z equivalent. Therefore I is nothing but E by Z equivalent here. So the value of E is directly given in the problem. Z equivalent we had just now calculated. So just substitute it over here and finally the value of current is calculated as 68.12 with an angle of 100 degrees, right? If you want, you can even convert this into rectangular form also, right? So here comes the end of this problem. If you have any doubt related to this, let me know in the comment section. Thank you.